The method of proof that I want to talk about in this video is what's called proof by contrapositive. Now that is a very elaborate sounding name, but essentially what it means is if the original statement is true, then the full negative reversal of the original statement must also logically be true. And it's a way that we can approach certain things where the original statement might be tricky to prove. However, if we negate the entire thing and look at it from the opposite perspective, that could be much easier to prove, and that could be much easier to work with. Now, some forms of proof depend upon the fact that a statement and its contrapositive are logically equivalent. Now, this doesn't necessarily hold for every single statement that's out there, but a lot of forms of proof depend on it. Now, a contrapositive is formed by negating both terms of the statement and forming a new statement based on this, which is essentially the negated version of the original. So for example, if the original form is of if P then Q, then the contrapositive of that is if not Q, then not P. So originally, if this happens, then this happens. The contrapositive of it is if this doesn't happen, then the original thing doesn't happen. A couple of examples for you. Imagine this statement, if it is raining, then the grass is wet. Well, the contrapositive to that statement is if the grass is not wet, then it is not raining. Another statement could be for any integer k, if 3k plus 1 is even, then k is odd. The contrapositive to this statement would be if k is even, then 3k plus 1 is odd. So you notice how we're changing the statement, but we're not just changing one slight part of it like we would with proof by contradiction. We're changing both parts of it, so logically it's still the same. We're just essentially approaching it from a different angle. Now this is the kind of thing that is easiest to be seen in action and with practice. So I'll show you a couple of examples of what I mean. So let's take this statement here. Prove that if 7x minus 1 is even, then x is odd. So what I want to do to start with this statement is I want to start to build up my contrapositive. And I want to start to approach it by thinking to myself, how can I look at this, again, essentially, from another perspective? Now remember what we said earlier. We're going to look at a statement being set up as if P, then Q. And in order to reverse it, what we're going to say, if not Q, then not P. So we're going to start essentially at this end and then look at this part here. So swap around the order of the P and Q and how we approach it. So we're going to start by saying, well, in this case then x is odd. So what I'll start by saying is if x is even, because that'll take that Q part of the statement and totally flip it on its head and negate it. Now the original part of the statement, the if P part, was if 7x minus 1 is even. So in this case I want to negate that as well. So I'm going to say if x is even, then 7x minus 1 is odd. So that's essentially me taking that if P then Q statement, and I've now written it in the format if not Q, then not P. So what I can now do is look to use that contrapositive and solve the equation in this statement so that I can prove it. So if x is even, then 7x minus 1 is odd. Well, if x is even, what we're going to do is we're going to let x equal something of the form 2k, because 2k will always give us an even number. What that means then is I'm going to substitute it in, and I'm going to do 7 times 2k minus 1. So that's then 14k minus 1. Now this part here, the 14k, that's always going to be even. 14 is an even number, multiplying by an even number always gives you an even number. So again, it's going to take the format of 2 times something, let's call it 2m in this case. That means that the whole statement will become 2m minus 1. So 2m minus 1 is always going to be an odd number. Because it's always an odd number, that means that we've now proven this part of the contrapositive. So by flipping it and going from the if P then Q to the if not Q then not P, I've actually made it easier for myself to prove, and I've proven this original statement here because the logic follows through and the logic holds for both sides of the statement and both perspectives we look at. Hopefully that's clear enough. Let's look at a slightly more complex one. So this one here says, prove that if a plus b is greater than or equal to 9, then either a is greater than or equal to 5, or b is greater than or equal to 5 for any integer a or b. So the first thing we're going to look to do is we're going to look to build up a contrapositive statement and see how we would look at it from that perspective. So if we look at the original, it's saying if this, then that. So if a plus b is greater than or equal to 9, then either a greater than or equal to 5 or b greater than or equal to 5. So let's start to build it around that statement and let's start to look at it from another perspective. So from the other perspective, instead of a greater than or equal to 5 or b greater than or equal to 5, what I'm going to say is if a and b are less than or equal to 4, what that means is that a plus b has to be less than 9. So I've taken the statement and I've turned it around on its head. So if a and b are less than or equal to 4, then a plus b has to be less than 9. So I've taken the if this, then that, and turned it into if not this. So if it's not greater than or equal to 5, either or, I've taken it to be if both. And then can't be greater than or equal to 9, I've turned into has to be less than 9. So let's imagine what that means then is a is less than or equal to 4 and b is less than or equal to 4. Even if I then take my max values, so a being equal to b being equal to 4, what that then means is a plus b at most has to be less than 9, because a plus b would be 4 plus 4, which is less than 9. So it would then hold for that side of the coin, hold for that statement. What that then means is I can go back to it and I can look at it and say, right, well, my contrapositive, that's true. So logically, because the contrapositive is true, my original statement has to be true in itself. So I'd say a statement along those lines. So because the contrapositive is true, what that means is the original statement is also true. So I've proven it from one perspective, which means it has to hold for the other perspective as well. Working with proof by contrapositive has its benefits and can be worked well with certain more complex scenarios. The key is getting that first part, getting that contrapositive statement. And it's just essentially remembering the same format of if P then Q being the original statement and turning it into something of the format of if not Q then not P. So essentially looking at it from that way. If you can nail that part and get that statement nailed to begin with, working with it should make your life a bit easier and actually should then help you when it comes to proving things using this technique.